Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining the MAC address table. As we saw in the previous video, the MAC address plays a fundamental role in many areas of Layer 2 network operations. One of the most important is the use of the MAC address to populate the MAC address table of a switch. The MAC address table is a construct within the memory of a network switch that corresponds host MAC addresses with the switch ports of the switch. It's used to correctly forward frames out of the appropriate exit interface. Now take a look at this network here. Note I've abbreviated the MAC addresses of these hosts simply for convenience. You can assume that they're correct 48-bit values. When a frame enters the port of a switch, two things happen. First, the source MAC address of the entering frame is used to populate the MAC address table, associating it with the ingress port. Since a frame with a source address of EEEE arrived on Gigabit Ethernet 3, this means that this MAC address can be reached via this port. Second, the destination MAC address is read. It is looked up in the MAC address table, and if it exists, it's forwarded out of the corresponding switch port. If it does not exist in the MAC address table, as is the case here, the frame is actually forwarded out of every other port of the switch, except the one it came in on. So in our case, we don't see the MAC address of the destination, which is CCCC, in the MAC address table. So it's sent out of all ports. Now all of the hosts receive this frame, but only the host with the specific destination MAC address receives it and processes it. The rest of the hosts simply drop it. Now when this host prepares to respond and sends out a frame to this host here, the source MAC address is read and the MAC address table is populated. Now we have the MAC addresses of this host in the MAC address table with its corresponding interface of Gigabit Ethernet 1. So all future frames that are sent to this destination will be sent out of that port alone. Next, the destination MAC address of this transmission is looked up in the MAC address table, and a matching egress port is actually found here, Gigabit Ethernet 3. And this is the entry in the MAC address table that it was originally put there from our original frame. So based on this, the frame is forwarded out of Gigabit Ethernet 3. Now throughout this process, as more and more frames are exchanged between hosts, the MAC address table becomes populated, resulting in a mapping of unique MAC addresses and the interfaces through which they can be reached. But a MAC address entry in the table does not remain there forever. It has a timeout or an aging timer of 300 seconds or 5 minutes by default on Cisco switches. Other vendors may have slightly different timeout values, but the principle is the same. MAC tables are not infinite. Switches have a finite memory capacity, and when that table fills up, it can cause excessive flooding and degraded performance. So this aging timer ensures that the MAC address table, which takes up memory in the switch, does not get overflowed, especially in scenarios and environments where many users may connect and disconnect continuously, like a Wi-Fi network that may be connected to a physical switch. In such a case, assuming this access point is operating at layer 2, all the devices that connect to it will have their MAC addresses assigned to the Gigabit Ethernet 4 interface in the MAC address table of this switch here. If you have hundreds or even thousands of people connecting and disconnecting on this wireless network throughout the day, it will result in a very large MAC address table. The MAC addresses of those hosts that connected for a while and have left need to be flushed out of the MAC address table frequently in order to avoid overflowing. And that is why the 300-second aging timer has been enforced by default. Now, what happens if I have two switches like this? Each switch maintains a MAC address table based on the frames it receives, and each switch will populate the MAC address table for hosts that send traffic that may not be directly connected to the local switch. For example, if this host here sends a frame to this host, the Gigabit Ethernet 4 interface of this switch here will populate the local MAC address with the AA MAC address. Similarly, these hosts may also send traffic to this host, resulting in the same ingress of frames to Gigabit Ethernet 4 of this switch. The result is that one switch port may correspond to many MAC addresses, especially in a scenario like this one, where many hosts can reach this host here through this single ingress port. So it is possible to have many MAC addresses correspond to a single port, but you cannot have many ports corresponding to a single MAC address. This, by definition of the uniqueness of the MAC address, should not take place. You can't have one device connected to two ports. If we do see MAC addresses appearing on multiple ports in a switch, it results in what is known as MAC address flapping. When a MAC address is corresponded to a particular port, if it suddenly appears on another port as well, it's deleted from the original port and it's assigned to the new port. If this happens continuously, the MAC address is said to be flapping between ports, something that can occur if a misconfiguration or a bad network design is applied. In any case, this phenomenon is something that's undesirable and may cause unpredictable behavior on your layer 2 segment. Now, the MAC address table is sometimes called the CAM table. This is because MAC address tables use the CAM memory of a switch. CAM stands for Content Addressable Memory. Now, CAM is a special type of memory that makes MAC address lookups very fast. Instead of looking up data by an index, the switch searches the CAM table by content, specifically by the destination MAC address. In conventional software-based searches, entries in a table may need to be examined one by one until a match is found. As the table grows, this kind of lookup becomes slower and less efficient. Indeed, as each entry is examined, one CPU cycle is used. So in order to find your MAC address, you may need dozens or even hundreds of CPU cycles to find it. But CAM works differently. It compares the search value against all stored entries simultaneously, in parallel, using dedicated hardware logic. This means that the lookup time stays constant. It takes only one CPU cycle to find your MAC address, even as the table grows in size. So when a frame arrives, the switch checks the destination MAC against its CAM table and immediately, in one CPU cycle, knows which port to forward it out of. This is what allows switches to make forwarding decisions at what is known as line rate, with extremely low latency. Now, in the MAC address table on some switches, you will typically see one more column of information, and that's the VLAN number. The MAC address table also marks down to which VLAN that MAC address belongs. This is necessary because VLANs create separate layer 2 broadcast domains within managed switches, something that we'll talk about in an upcoming video. When a switch receives a frame, it doesn't just need to know which port a destination MAC is on, it also needs to know which VLAN that MAC belongs to. Frames must only ever be forwarded within their own VLAN, not across VLAN boundaries. So instead of simply mapping MAC address to port, the switch actually tracks MAC address and VLAN to port. This ensures that traffic stays inside its assigned VLAN and does not leak into other network segments. This is especially useful when the MAC address is not found in the MAC address table. When the switch floods the frame out of all of its ports, it will only flood it out of those ports that belong to the same VLAN as the incoming frame. When a frame arrives, the switch first identifies the VLAN it belongs to, and then performs the MAC address table lookup within that VLAN scope. This is what allows VLANs to provide proper segmentation, isolation, and scalability in layer 2 networks. But we'll talk more about VLANs in a later video, so stay tuned for that. So that's an overview of the MAC address table. Now, if you made it this far into the video, I want to thank you very much, because that tells me that you really care about understanding this stuff, and I really appreciate that. If you want to go deeper, I've recently launched my website at telecomTech.io, where I'm building full courses with labs, quizzes, and real-world configurations. There aren't many courses there yet, but many more are on the way. So check it out, subscribe to the newsletter, and get early access and better deals on future releases. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.